Okay, so today we're going to finish with our review quiz practice. This is where we were left to pick back up at. We have a cyclist who rode the first 20-mile portion of his workout at a constant speed. For the 16-mile cool-down portion of his workout, he reduced his speed by 2 miles per hour. Each portion of the workout took the same time. Find the cyclist's speed during the first portion and find his speed during the cool-down portion. So, since the amount of the workout time was the same, what we're going to do for this problem is we're going to set up a proportion. If he rode 20 miles at a constant speed, that's what we're going to begin here. So as we start our proportion, we have 20 miles at a constant speed. For the cool down portion, it was 16 miles and he reduced his speed by 2 miles per hour. So miles are on top, the speed is on the bottom. So if he reduced it by 2, we would take the constant and subtract it with 2. So as we go to solve this, what we're going to do is we are going to cross multiply here, and we're going to cross multiply here. Okay, so what we're going to have is 16x equals 20 times x minus 2. So on the right-hand side, we need to distribute that 20, and that gives us 20x minus 40 when we distribute here and here. I'm going to move my 20x to the left, so both x's are on the same side. 16 minus 20 is negative 4x equals negative 40. You're going to divide both sides by negative 4, and that leaves us with x being negative divided by negative would give me a positive 10. So the constant speed that they're asking for, the x, is equal to 10. For the cool down speed, that was x minus 2, which is 10 minus 2. So the cool down speed is going to be 8. Okay? Next, we have Sally. She can paint a room in 9 hours, while it takes Steve 3 hours to paint the same room. How long would it take them to paint the room if they work together? Okay, so we have Sally and we have Steve. We're going to have them painting the room individually, but then we're also going to have a time of how long it takes for them to paint it together. So let's look back at the amount of time again. Sally, 9 hours, Steve, 3 hours. So Sally can paint one room in 9 hours. Steve can paint one room in 3 hours. If we add those together, they can paint one room in X amount of time. So this is actually doing a little bit of that practice of finding, we need to find a least common multiple. If we have a denominator of 9 and a 3 and an x, 3 actually goes into 9. 9 is a multiple of 3. So we can use the number 9. We also have an x involved in the denominator, so we have to have all of the factors. We need the 9, the 3 is part of the 9, and an x. So what we're going to do once we find the least common multiple is we're going to multiply every single term by 9x. This is like what you're going to do in section 5 when you're solving equations. You'll find a common denominator. You're going to use that to cancel out all denominators. So here, the 9 and the 9 cancel. I'm left with 1 times x, which is just x. Here, the 3 cancels, and the 3 goes into 9 3 times. 3 times 1 is 3, and we have the x, so that's 3x. Here on the end is the x's that cancel, and 9 times 1 is 9. So when I combine like terms, this is going to give me 4x equals 9. Divide both sides by 4, and x is equal to 9/4. That fraction cannot be reduced, and that would be how many hours? If you'll notice in the problem, I'll go back to it, they want you to leave it as a fraction. Don't choose a number or a decimal. I know it looks odd to talk about time as a fraction, but just leave it in that format. Because here it says type an integer or a fraction. So integer would be if it simplified to a whole number, which it does not, or just a fraction, and in this case, it's an improper fraction. Okay, now this is going to be another proportion. So what I'm going to do is I'm going to draw my two triangles, and then we're going to come back and label those. So what we have is two similar triangles, and both of these are going to get labeled, and we're going to set this up as a proportion problem. So we have 13, 22, x, and 33. 13, 22, x, and 33. We're trying to find the length of x. So the 13 is on the left, the 22 is on the bottom. So when I put my values here, I look at this triangle and I ask myself, what's on the left? That would be the variable x. What is on the bottom? That would be our number 33. So from here, we now are going to solve this as a proportion. You're going to cross multiply, and then you're going to divide 22. Okay? Or we could write it out longhand. But if I did this on the calculator, I would simply do 13 times 33 divided by 22 would give me a length of 19.5. If you do it longhand, you can say the 22 times x, 22x, equals 13 times. You would do 13 times 33. That gives you 429. You're going to divide both sides by the 22, and then x equals, here, divide by 22. And as you see, it's the same thing I did in one keystroke here versus I did it in 2 steps here. And that would give you 19.5 would be the length of the left side. Subtract, simplify the result if possible. Okay, 2x plus 1 and we have x squared minus x minus 56, and that's the same, I believe, for both. Yes. And then in the numerator, we have x minus 6. Now, for this particular problem, when we go to subtract, if you will notice, both denominators are the same. So we do not have to find a common denominator. However, we do need to factor that denominator. They're both identical, so we're going to do negative 56 divided by x, and we're going to look for 1. So we're going to do here, we need to put y1 plus x. And here we're going to clear and do negative 56 divided by x. Second table, and we're going to look for a negative 1 in the third column. It gives us a minus 8 and a plus 7. We get a We get a -8 and a +7. In the numerator, we have 2x plus 1 here, and then we have a minus. So let me show you what's going to happen. Let's just recopy the 2x plus 1. What we do not see is there's an understood -1 here. We're going to distribute that -1. That's going to give us a -1x, and a negative times a negative gives me a +6. So what we're now going to do is we're going to combine our like terms. So we're going to take 2x minus 1x, and that's going to give us an x. We're going to take the +1 plus 6, and that's going to give us 7. That is over x minus 8 and x plus 7. So we combined like terms here. Once I've combined them, now this would be like what you would have done in sections 1 or 2, where you're simplifying this rational expression. What do I see here that can cancel out? The x plus 7 is identical. Now, a common mistake is that somebody's going to give x minus 8 as the answer. That is not correct, because I want you to notice, where is the x minus 8? It's in the denominator. When the x plus 7's canceled, technically they cancel out as 1 over 1. So what you have to remember to do is put the line for the fraction, because this is in the denominator, and then you've got to have a placeholder of 1 in the numerator. Okay? Find the domain of the following rational expression. Okay, so we've got h of x and negative 8x squared, x minus 5x plus 6. And they want us to find the domain. Remember, the domain are the x values. Also remember from section 1, even though this technically is the last section in 70, it's also the first section. Finding the domain or the x values includes finding what makes it undefined. So we need to know what makes the denominator equal to 0, or we can use the word undefined. So if we take x minus 5, set it equal to 0, and we take x plus 6 and set it equal to 0, we just simply move that value to the other side to solve for x. As we do so, we have two values. The formal way the answer is written is the domain of h of x is all real numbers except, and the exceptions are the two numbers we just came up with. So the answer is going to be all real numbers except, and the two exceptions are a +5 and a -6. So you would just type in those two values. So this, like I said, is just like section 1. You're just determining what makes the denominator undefined. Add, simplify the result if possible. Now, the beauty of this is both denominators are the same, okay? So we have 1 over 2 plus y. The denominator was the same. Let me go back and see the second numerator was y plus 5. So in this scenario, the denominator does not change. It is the common denominator. At the top, there's a plus sign here, so we have a 1 plus y plus 5. So we're going to combine the 1 and the 5. So that's going to give us y plus 6 in the numerator and a 2 plus y in the denominator. At that point, stop. You're finished. You cannot cancel the y's nor reduce the 6 and 2, because If it helps you, put a parenthesis around those. They are a unit within themselves and they cannot be reduced in any way. So that would be your final solution. Multiply, simplify if possible. Okay, so we've got 8x plus 8 over 7. And we have 14 over 32x plus 32. Okay, what I would start by doing is I would take this numerator and see if I can factor out a common factor. I can factor out an 8, and that would leave me with an x plus 1. My denominator is still just a 7. This is still 14. On the bottom, I can factor out a 32, and that leaves me with an x plus 1. So what I did first was I factored all that I could. Now what do we have in common? X plus 1, that's going to cancel out. So what I will now do is I'm going to multiply the numerators and multiply those numbers in the bottom. So we have an 8 times 14. So we have 8 times 14. That gives us 112. So our numerator is 112. The denominator is 7 times 32. That gives us 224. All we have left to do is to reduce this fraction. So we have 112 divided by 224. We get a decimal, press math and enter 2 times, and that simplifies to the fraction 1/2. So your final solution here is 1/2. If y varies directly as x, find the constant of variation and the direct variation equation for the solution. Y is 28, x is 8. Okay, y is 28, x is 8, and they tell us y varies directly as x. The equation for direct variation is y equals k times x. This, I believe, is section 7. There's 3 variation equations: direct variation, inverse variation, and joint variation. On the test, you will have both direct and inverse. So write your equation. Then we're going to plug in the values for x and y. So we have a 28 equals k times 8. Our objective is to solve for k. What they want us to do is for k, and then they want us to rewrite the equation using the value k and just letters x and y. So I have to divide both sides by 8, and that gives me k equals, we are going to do 28 divided by 8, and we're going to simplify. We have 3.5, or we could do math, enter, either way, 7/2. Here, it does say simplified fraction, so we don't want to use the decimal, we want to use the 7/2. So that means the answer for k would be 7/2. So k equals 7/2. When you go back and write the equation, we're just going to write the same thing we have at the beginning, y equals, but then we're going to write the fraction 7/2 where k goes, and then just the letter x, and you're done. It's no more complicated than that. Write an equation to describe the variation. Use k for the constant and proportionality. W varies inversely as p. So they tell me W varies inversely as p. So what you want to do is identify the inverse variation equation. That would be y equals k over x. That is the equation for the inverse variation. All we have to do is adjust it by replacing and using the letters w and p instead of y and x. So we would write it as W equals K over P. That's what they're going to be looking for. So identify it in the form that we use with the X and the Y, and then substitute the letters that they chose. Simplify the expression. Okay, so this is just section 1, factor and cancel out things that are the same. Okay, so 2x squared minus 3x minus 20. 2x squared minus 3x minus 20 over x squared minus 6x plus 8. So if I factor the numerator, there's not a common factor. I would factor both terms. They start with x. I have to remember, since there's an a value at the front, to divide by 2. So 2 times negative 20 gives me negative 40. So on the calculator on y equals, we're going to do negative 40 divided by x, second table, and our middle term was a negative 3. So here's my negative 3. We're going to use a negative 8 and a positive 5. Negative 8 and a positive 5. I need to simplify this. So this numerator here is going to become x minus 4. Here I'm going to do bottoms up, and that's going to become 2x plus 5. So this is my numerator. My denominator here, I'm going to factor into 2 terms. They're both going to start with x. There's no leading coefficient. So we're going to do 8 divided by x and look for negative 6. So here we have 8 divided by x, second table, and we're looking for, okay, I'm going to have to go the other direction a little bit to get to some negatives. Cannot use the positive 6. I've got to go until I find the negative 6. Okay, there we go. There's our negative 6. So I have a negative 2 and a negative 4. A negative 2 and a negative 4. Now that everything is factored, I look and see, is there a common factor? This is my denominator. What can we cancel out? The x minus 4 is the same. So my final answer is going to be a 2x plus 5 over x minus 2. Match the function with its graph. So we have 25x minus 5, 25x minus 5 over x squared minus 6x plus 9. So you're going to go to y1 equals, and you're going to type equation. When you type in the equation, what you're going to need to remember to do is that you want to put parentheses around the numerator and the denominator. So when you type it in, you're going to have a parenthesis 25x minus 5, close your parenthesis, divided by parenthesis x squared minus 6x plus 9. You've got to have parentheses around everything. Then you're going to press graph, and you're going to start, and you're going to go to zoom 6, which is the standard view, to be able to see it. Okay, so let's go to our calculator. We're going to go to y equals. We're going to clear everything out. The mistake is people type it on y1 and y2. It's all typed on one row. 25x minus 5 divided by x squared minus 6x plus 9. Okay, we're going to press graph. And if I'm not at the standard view, and if you're not sure, then please, by all means, just follow these steps. We're just going to do zoom 6, and that'll make us be sure we're at the standard view. And then we're going to compare this to the graphs that we see on the computer. So we have a little arc on the right side of quadrant 1. This comes down quadrant 1 and out on quadrant 3. So it's not this, it's not this, not this. It's actually A. That would be the correct graph. Okay, now this is like what we did a moment ago with the inverse variation. Okay, so it was here. Actually, let me draw this up here. So we had a little piece here, and then it looked like that. Okay. I need a new slide. Okay, so for this problem, the wavelength of a wave varies inversely as its frequency. So we have an inverse variation. So that would be y equals k over x, inverse variation. But they're not using x and y, they're using wavelength and frequency. So we're going to write wavelength equals k over f. So that's the first thing we do. The second thing is, so the wavelength of a wave varies inversely as its frequency. We wrote the equation. A wave with a frequency of 1300 has a length of 182. The length is the wavelength. So the W is 182, the frequency is 1300. So we have 182 equals K over 1300. The next step is that we want to solve to figure out what is K. So we're going to multiply both sides by 1300. And K is 182 times 1300. Oh, wait a minute. 182 times, I was a zero short. 236,600. 236,600. So now my equation is W equals 236,600 over frequency. So that's now my new equation. Now they're asking us a question. What is the length of a wave with a frequency of 700? So we want to know what's the wavelength if your frequency is 700. So the wavelength, we're going to divide by a frequency of 700. And that's going to give us our final solution of that amount divided by the 700. We have a wavelength of 338. So you've got to do 2 steps on that. You solve for K, write your new equation, but then you have to plug in their value they give you to answer a new question. And we are almost done with these. We've got 2 left. Find the quotient and simplify. So quotient means this is a division problem. So that means the left side of the equation I'm going to write down just like it is. I'm going to change the division to multiplication, and then I'm going to write the reciprocal of the one on the right. Okay, so first let's write what we have first. X squared plus 9x plus 14. So we have x squared plus 9x plus 14 over, I believe it was x minus 1. The division sign we're going to change to multiplication, and now we're going to write the reciprocal. So the x minus 1 is going to come up to the numerator. And then we had an x squared minus 6x minus 16. I think I copied that right. Yeah, okay. So we're just going to factor and leave our answer in factored form. So this is already factored, and so is this. So what I've got to do is factor this numerator here and here. This is the x minus 1. On the bottom, this x minus 1 is already factored, but then I have to factor this denominator into 2 parts, okay? So let's go about doing that. So let's start here in the top. 1 times 14, and we're going to be looking for a 9. So 14 divided by x. Oh, wait a minute. How did that happen? I was trying to go to the, there we go. Okay, alpha trace 1 plus x. Okay, there we go. So I'm looking for a positive 9. Here's my positive 9, either here or here, but notice the answers are the same. 2 and 7, 7 and 2, they're both positive. So we've got a plus 2 and a plus 7. For this one, we're going to do negative 16 divided by x, and we're looking for a negative 6. So negative 16 divided by x, and we're going to look for a negative 6. Here it is, negative 8 and a positive 2. So we've got a minus 8 and a plus 2. So now that everything is factored, we're going to go about and see what can cancel. This x plus 2 here and here are going to both cancel. The x minus 1 here and here are going to cancel. And we're going to be left with an x plus 7 over an x minus 8. I would suggest still put the parenthesis around because I don't want somebody to accidentally try to mark out those x's. They cannot be canceled. We can only cancel things when it's on factor, which means everything is being multiplied. There's no pluses and no minuses. Okay, so this will be left in this form. And then last but not least, the quotient of a number in 3 the quotient of a number and 3 minus 2 equals 5/3. Minus 2 equals 5/3. And they say find the number. Okay, quotient means division. So we have the quotient of a number and 3, comma. Then it says minus 2. So subtract 2 equals, and we have the fraction 5/3. This will be just like section 5. You're solving for x. So what we do is we find a least common multiple. Now this case, the least common multiple is going to be, it's all one number. It's a 3, that's an understood 1, and that's a 3. So to get rid of the denominator, we're going to have to multiply every single term times 3. 3's cancel, I'm left with x. Negative 2 times 3 is minus 6. Here, my 3's cancel, I'm left with a 5. One last step, move your 6 to the right-hand side. X equals 5 plus 6 is 11. And voila. This module is not nearly as hard as you may have been thinking from the beginning, and you can do this, okay?